Hello, everybody. This talk this evening is about how you know what happens with your server, how you can use GFR to know what happens when you drop your serverless function in the cloud and when it is running there. So, out of interest, who is all running serverless functions? And with a GVM? Perfect. This talk is for you. So, all the others are also welcome. And I'm software engineer in the Aerts cloud team. With Aerts, we sell smart Wi-Fi solutions to telecom operators. And the Aerts cloud team is a team of a few software engineers, both in Istanbul as here in Antwerp. And we build, maintain, deploy, and operate a big data system to monitor, analyze, and optimize Wi-Fi experience, the Wi-Fi experience of your home. So the chance is high that we are optimizing the Wi-Fi in your home even. On Wednesday, there is an interesting talk of Paul, who's sitting there, who will tell you how we ensure the privacy, with our architecture, ensure your privacy in such a sensitive environment. All the code which you will see, and you can also run the demo today on my GitHub account. I will also add the link, for example, to the YouTube recording once it becomes available. So, when we have such a system, a big data system, and we need to add functionality, one of our first design principles or things we think about when we think technically is how can we run this serverless? And why do we make this kind of reasoning? Because serverless does not require that much management. Once you have deployed the code, you are almost guaranteed that it will more or less scale. It's pay as you go, so after you've implemented a feature and it becomes widely popular, you pay for it, but if nobody is using it, you don't need to pay for it anymore. So it's also easy to calculate what it will cost. But the runtime environment is sometimes a black box. One of the typical things you do, it works on your developer machine, you deploy it to the cloud, and it does not really work how it should be or how it works locally, especially if you look at performance. And there is no easy way to SSH to the machine, attach a debugger, see what is going on. With GFR and I hope with what I'm showing here today is that you will be a little bit teased to try what can I see with GFR if you encounter these kind of problems, because you can see a lot. So what is GFR? Java Flight Recorder is a profiling and event collection mechanism which is by default available in every recent GVM. It's rather low impact. The profiling setting I will use today has 2 to 3% overhead. If you run it with default settings, it's only 1% overhead. So let's start looking at code and let's see if everything still works. So my demo today, I will start with one of the most easy. Is it readable, the font, I guess, in the back? Perfect. So I start with the most easy Lambda I could think of, which still does something. It is Lambda, which will, so I'm using here AWS, but whatever it also works on Google Cloud, and I guess you can also get the method I'm talking here about also working on Azure. So what I'm here doing, I'm using an AWS S3 client, and I list which buckets I have there, which is just an API call to S3 to Amazon. Okay, and okay, let's remind myself that every time before I start a new step, I already deploy it, or I ask Sam to deploy it. So what else do I have? It's a template.yaml. And this tells Sam on how he needs to deploy my Lambda to AWS. So I have here a function. I'm using Java 11, which is, sadly enough, the latest version of Java you can use by default on a serverless function. I use a rather low memory size. I'm saying rather low because the memory size not only defines the memory, but also defines the amount of CPU your function gets. I refer to that lambda you saw before, which function it needs to call. So it will initialize the class and call the function, where Gradle has put all the sources for the lambda. And I will also create a function, a URL, where I just can call the lambda without having to go over any AWS API. And I will output that function here, and Sam is nearly there in deploying this function for us. So I can just curl that function you have seen before, and it will take, with this lambda, 13 seconds before the full data is loaded up. Because what will happen, Amazon will, or the AWS Lambda environment will start up a GVM, so a container image with all my sources. It will initialize my class, and after it has initialized my class, it will call my function, obviously. I also have a small load test script, and that will just call this function 10 times, because after it is initialized and my method call is over, of course, the GVM is more or less frozen, and when the next function call comes in, it will be unfrozen, and it will go a lot quicker than those 14 seconds you've seen before. So my load test here shows me that it's 300 milliseconds. Of course, 14 seconds startup is too slow. Why is it so slow? And let's see if we can fix anything about this. So I will check out step 1, and in my step 1 just enables the Java flight recorder, so I can look into my Lambda and see what is happening. So in my template, the only thing I add extra is some GVM options to start the Java flight recorder from the first moment the GVM is loaded. So I don't do this out of code, because then I see the first moment the GVM sees light. I increase the stack depth a little bit because it's just too low to see what is happening. So by default, it records only 64 stack frames with 128. I get double of them and have enough. And I'm also having a circular buffer. So what GFR does, it will record hundreds of events or thousands of events per second. It has a circular buffer, and I'm here saying limit that buffer to 50 megabytes. And when it is full, it will drop the oldest events again. And settings profile will say, so there are a few profile settings, and I will just make it granular so I see enough events. And of course, I forgot again to deploy this, and I don't want you to wait for it. Okay, so that means how the recording works. If you have worked with GFR, you can ask it, for example, to dump the file on exit, but in that Lambda, the environment is gone. So one of the rather naive trick I'm currently using is inside my Lambda, I just added here, if a request comes in with an HTTP query string $GFR at the end of my URL, I will update a GFR dumper. And that GFR dumper is a small class I wrote, rather simple code, which will dump, so it will take the ongoing recording, so it will see, are there any recordings ongoing? It will take the first ongoing recorder, first dump them to the local file system, tempfs, and then upload it to S3. And once it is in S3, I can download it to my machine and look at it with Java Mission Control to see what is happening. So it's rather easy, rather straightforward, and it's just in time there. So I will now run my load test script again to just do 10 calls. Of course, I again have here my 13, 14 second-ish cold start, which I don't want, of course. And then we will have around 400 milliseconds between each request, which is also too much. But let's now, I have a script, getGFR, which for that URL will call it with the question mark GFR parameter, will dump it and bring it to my local machine. So let's open it in mission control. I'm now doubting. So with open file, and of course, demo, it was not around the correct directory. We are the 10th today. It is the correct GFR trace. I will open this one because it takes too long otherwise. All right. So what are we seeing here? We're seeing here more or less an overview of all events GFR is generating for us. It generates a lot of events. The ones I'm now going to look at are the method profiling events, but you can have CPU usage. If you are more interested in object generation, you can zoom in on allocations. If you're interested in garbage collection runs, you see all your garbage collection runs, which are happening in my Lambda. Logs, I/O, but let's now keep it simple and look at method profiling. So what will happen is that more or less for every thread you have 10 times per second, it will take a stack frame per CPU second, I think. Not that sure. And it will show you what is happening. So what we are seeing here, we are seeing that we have here 128 samples, and we see here that it's spending a lot of time in S3 client creation. So that client I have is created for every function call, which is of course not a good idea in a Lambda. What you want to do is you want to move these things to initialization time and reuse them every time the method is called. So the initialization works. So let's do that, and let's see what is happening now. Step 2, mesh. What did I do? In my Lambda, the only thing I did is I moved the creation of the S3 client, which was created every time at line 21. I moved it now to 14, so it can be reused. We will now see normally two interesting things. But I'll have to wait. I should have started earlier. So let's wait. Nearly there. So we'll do the load test again. And the first interesting thing we should see is that the first call is taking now 8 seconds instead of the 14 seconds. So even though you would have thought that the first API call would take the same amount of time, as the same amount of work needs to be done, you see here that you're already losing 1/3 of your timing of the slow start, cold start. And for those who have worked with Lambdas, you probably know this is, but we should also be able to see it. This is because initialization time of a Java container in a AWS Lambda will get more CPU than when the function is called. So you get 10 seconds of burstable CPU, and that burstable CPU is also clearly visible here on the top. So these are my 10 function calls. This is the initialization of here around this time is my initialization. And what you will see here, that you have here a lot longer, if you compare it with the previous run, you have a lot longer that you are allowed to burst your CPU. So the initialization time of function is not only free, because you're not paying for the initialization time, as long as you don't take it too long, but you also have a lot more CPU to do things. So this is like, so you will also see this if you look for the Amazon documentation, but they don't explain this that clearly, but they say, try to do as much as things as possible at initialization, and that's because of this. You get more CPU room than after the initialization is finished, because then your CPU is again throttled and limited, especially because I'm at that 512 megabyte limit. I'm making sure you see this kind of throttling a lot more. We can even go a step further, which I will first deploy before I explain what I'm doing. Otherwise, you all have to wait for it. So if you look at the Amazon documentation, what the next thing they will say is, and that's also something we have seen, we can clearly see here, we're still spending a lot of time in creating the HTTP clients, the Apache HTTP client, and also setting up the first connection. That's something Amazon also clearly tells you if you read the documentation, that the HTTP library is not that performant for Lambdas. But there is no problem. What you can do is you can switch the HTTP library. There are two ones available. I took here the preview one, so it's the Amazon Custom Runtime library. And if you use that one, they have their own HTTP implementation. It is still in preview, but I guess in the coming months or weeks, they will remove that preview label because it's looking rather stable. Because you switch to another library, that initialization takes a lot less time inside your Lambda. So let's see what we now have with the load test. It should be around 4 seconds. Oh, it's 5. On my machine yesterday, it was still 4. So we went from 8 to 5 seconds. We can still go further. Let's look at the GFR. We can still optimize further. There are other things you can do, especially in tuning your GVM. I have on my slides a few links if you're really interested. But this is not tune your Lambda and make it as fast as possible session. It is, let's look in GFR if we can see these kind of effects and see how we can optimize them. Still 13 minutes left, that's nice. It's going faster than I hoped for. So we will now see something interesting, I hope. And that is that the Java profiler only 28 frames left. And what we will see is that, and this is a typical thing you will see, is that you are micro-optimizing so much things that your profiler only has here 28 events, or this graph is only generated with 28 events. And you should now stop looking at this graph because it is not representative of your flow anymore. It's just 28 random samples, and it's not that one of those peaks is really representing 10% of your workflow. They just happen to pass by when your profiler passes by. If you hit this, you want your profiler to come in with a higher frequency rate. What I suggest here is that or you run it a lot more, or you use the async profiler. The async profiler has an option to hook himself into GFR and generate more events at a lot shorter time and a better resolution. And then your graph becomes again readable, and you can again look at things in a nice way. For example, another way how you can improve your Lambda startup is by this is one of the suggestions Amazon makes, and we did on a few of our Lambdas after we've profiled them like this, is disabling your C2 compiler. So what you will see is that at startup, we are spending around a second in compiling our code from C1, which generates machine code, but not to C2, which generates more optimized machine code. But if you spend a second there in something which only needs to live a few minutes and needs to be as fast as possible, it's sometimes a good advice to disable it. And things like GFR attached to your Lambda can give you this kind of confidence to do so. Also, in the presentation, there is a link to an Amazon article where they advise you or suggest that you can do this. So, if you've read the description of this talk closely, you would have seen that I've said you can also do this without changing one line of code. And you can by dumping GFR not from your Lambda, but with the Java agent you add to your code. I have an example of that one too. I don't think I will demo everything of it. I will just show you how the code works, and you can try it yourself. So what I'm now doing is in my template, I'm saying so first of all, I remove those 3 lines from my function. So there is nothing referring to GFR anymore, nothing triggering the build anymore. But what I will do is I will create a Lambda layer. So a Lambda layer is just an extra directory or a set of files you mount inside your Lambda and you can then use from within your option. And with that Lambda layer, which will be created, I will add a file to my function without changing anything of the function, and I will say this is a Java agent. So this Java agent will start up and it will do the GFR dumping for me. I kept the code on purposely rather simple of that Lambda layer. I just copied my GFR dumper code and I gave it a pre-main. For those who know, a Java agent needs a pre-main function, and that is the function which is called to dump it. Currently, I'm just dumping just at a fixed rate of every 30 seconds. But another way to do this is if you then also look in something recently released by Amazon, that is the extension API. So there is a possibility in AWS Lambdas to register an extension, and then you get 500 milliseconds to 2 seconds before the termination of your container, but you pay for them. But in those 500 to 2 seconds, you can then just, before AWS Lambda terminates a container, take your dump, send it to S3, and then close everything off. But that's a little bit more code. So that was all my code and all my demo. Let's see if I forgot something. In 7 minutes, and then I still have a few minutes for questions. I hope I wasn't too fast. So I start with the baseline. I enable GFR with a GFR dumper and a request parameter. I moved a lot of things to startup, and we saw that not only the function became faster, but also the initial startup became faster because you have a lot more CPU at that moment in time. I applied some Amazon advanced cooking magic, and it was even faster. We saw the resolution dropping, but we couldn't find it anymore. I showed you how you can also do it with a Lambda layer if you don't have access to the source code of the Lambda. Did I forget something? So that's the Lambda extension API I talked about. If you ever are in need to disable the C2 compiler to see if it works with your workflow, there is a link to that. The async profiler you can do if you want more high resolution. And the only thing I didn't talk about was custom events. Something you saw also if I looked at GFR is that it's not obvious from the UI where some Lambda starts and where some Lambda ends. Or if you want any other events of your code to be written to GFR, look at custom events. It's very easy to add. It's just making a class, giving the right annotations, creating the class when you want to generate the event. It will be automatically added to the whole workflow. And inside GMC, you can then zoom in and, for example, see which trace ID belongs to it, so you can then connect it with your code and your other instrumentation. As a lot of other people, we are standing here, we are also hiring, so if you feel welcome, always welcome on our page. And then I still have 5 minutes for questions. Any questions? Was I too fast? So, no questions? I was speeding up to make sure we have time for questions, but yeah?
What would be the alternatives to this solution? If you don't want to upload this JFR file every time to USB, like some online monitoring.
Yeah, you could upload it to other tools. It all depends. There are some monitoring tools which use something similar, not per se on lambdas, but you can do things like loggings and monitoring and metrics and when in doubt, see out kind of strategies. But I've never seen anything which gives you so much detail and richness over what is happening in GFR in a lambda. You don't have access to it. It's outside of your control. I've seen people who have some sidecar things where they can more or less connect over some kind of a WebSocket to their Lambda, but you're really hacking for a specific purpose. Like, this is more generic. That's what I like about this. Yes, CodeGuru Profiler. It does exactly the same. It uses GFR to send the right events to CodeGuru, but it gives you more a summary and not what happened with a specific application. So if you have a specific Lambda which has a specific failure state, CodeGuru Profiler gives you more or less the common denominator. Is that more or less an answer? Okay. So I think that was it. Yeah?
So in your demo, you are using the profile settings of
Yes.
It's a predefined settings.
Yes.
But in theory, you can tune this configuration.
Absolutely.
You can include or exclude some events. Is it possible to deploy Lambda with custom settings?
So the question is, can you deploy Lambda with custom settings? The thing I don't know if you can point to a custom setting file in an absolute path. Yes, you can. You can. I don't think you can do it at startup. But what you could do is, I think you can do it programmatically. So in your class initialization, you can load a configuration, and then you can load it from another location. Because the problem is, you cannot alter that location where that default file is, because that's under that's the responsibility of a cloud provider. They will not allow you to touch it. But what you can do is you can start a custom recording in your code initialization, but then you will miss the first 1, 2, 3 seconds. It is possible, and if you look at the dumper, it's more or less the same. You open your flight recorder, you say start the dump with a specific configuration, and adapt the configuration. You can do it with a Java agent even a little bit earlier in the path. That's, for example, what the async profiler does. Anything else from questions? Okay, that was it. I hope you liked it. Thank you.